Deep in the cosmic void past Pluto's orbit, something extraordinary is approaching. A minuscule point of brightness emerges from the darkness between distant suns, heading straight toward the inner regions of our planetary neighborhood. Its origin leaves no doubt. This traveler doesn't belong to our celestial backyard. Scientists have verified the arrival of a guest from beyond our solar family, marking only the third such discovery since the astonishing Oumuamua revelation in 2017. An unexpected discovery. During the middle months of 2025, an observatory facility in Chile identified this puzzling cosmic wanderer following an unusual path through space. The initial detection came through the Asteroid Terrestrial Impact Last Alert System, commonly known as ATLAS. This network constantly surveys the heavens, searching for unexpected objects. The detection occurred on July 1st, 2025, when ATLAS equipment at Rio Hurtado, Chile registered the object, initially tagged with temporary identification code A11PL3Z. It rapidly attracted scrutiny as orbital calculations revealed patterns unlike anything cataloged within our solar domain. Within 24 hours, the International Astronomical Union validated what researchers had begun to suspect. Humanity had encountered an interstellar traveler, earning it the official designation 3I Atlas. Consider what this represents. A fragment of frozen material and stone that has journeyed from another star's domain, now drifting through our cosmic region. For the scientific community, this represented a breakthrough moment. For the general public, it raised an unsettling concern. Should this alien visitor cause alarm? The comforting reality is that there's absolutely no reason for concern. From the outset, researchers established that 3I Atlas presents zero direct danger to our planet. At its nearest approach, the distance will exceed 150 million miles from Earth, approximately 1.6 astronomical units. This celestial visitor won't even venture closer than Mars's orbital path. Larry Deno, a key figure in the Atlas Initiative, acknowledged our limited understanding of this object's properties. For specialists, admitting uncertainty is simultaneously humbling and exhilarating because it signals the presence of genuinely novel phenomena. What scientists have learned. Current knowledge indicates 3I Atlas measures up to 12 meters in diameter, making it a substantial cosmic iceberg. During initial observations, it was positioned roughly 4.5 astronomical units from our star. The object travels at a remarkable velocity of approximately 40 miles per second, which translates to over 140,000 miles per hour relative to the Sun. No familiar frozen body from our system achieves such speeds naturally, confirming its distant ejection origin. Official documentation from the Minor Planets Center emphasized the exceptional nature of this discovery. Reports describe preliminary activity, resembling a traditional wandering ice body, including a marginal surrounding haze and a brief dust trail. In simpler terms, 3I Atlas isn't merely an inert rock. It's already demonstrating active characteristics, awakening under solar heating. A fuzzy envelope of released gases and particles surrounds its core, with a small debris trail forming behind. These observations occurred while 3I Atlas remained extremely distant and faint, at approximately 18th magnitude, far beyond naked eye visibility. The fact we detected it at all demonstrates astronomical progress. Global collaboration proved essential, with facilities in Hawaii and Australia contributing tracking data. By mid-July 2025, the conclusion was definitive. An interstellar frozen body was approaching. Comparing cosmic visitors. To appreciate 3I Atlas's unusual nature, we must examine its predecessors. The inaugural discovery came in late 2017, receiving the Hawaiian designation Oumuamua. The second, identified in 2019, was labeled 2I Borisov. Oumuamua presented a genuine enigma, an oddly elongated object without typical characteristics, showing strange non-gravitational acceleration that sparked intense speculation. Now we encounter 3I Atlas. Early indicators suggest it shares more characteristics with Borisov than Oumuamua. Though faint and fast-moving, it displays a typical fuzzy envelope indicating ice presence and evaporation. Importantly, no obviously anomalous behavior has emerged, just an extraordinarily interesting frozen body from another stellar system. However, one characteristic stands out: dimensions. The new arrival appears larger than both predecessors combined. Based on discovery brightness, astronomers estimate dimensions of approximately 9 to 12 meters across, substantially bigger than both earlier visitors. Another distinction involves approach direction. Oumuamua arrived roughly from Vega's direction. Borisov came from Cassiopeia. Our newcomer appears to originate from Sagittarius constellation, roughly from the galactic core region. Physicist Marshall Eubanks notes Atlas likely originated in the Milky Way's thin disk, suggesting formation around a star within the galaxy's vast spiral. All these interstellar visitors share one critical characteristic. They're not gravitationally bound to our sun. Each follows an open-ended hyperbolic trajectory, meaning they arrive, swing past our star once, and depart to interstellar space permanently. The current journey. Halfway through 2025, 3I Atlas approaches, while astronomers worldwide monitor it eagerly. Calculations indicate it will reach perihelion around late October 2025, at approximately 1.4 astronomical units from the Sun, just inside Mars's orbital path. The object will pass close enough to Mars that NASA's Mars Reconnaissance Orbiter might capture imagery. This frozen body moves extraordinarily fast. By perihelion passage, it should exceed 150,000 miles per hour, approximately twice Earth's orbital velocity. By April 2026, its relative velocity could reach around 55 miles per second, potentially making it a record-setting natural object. As of mid-2025, visible brightness hovers around 18th magnitude, far too dim for unaided eye observation. Predictions suggest that by August or September 2025, it may reach 15th or 16th magnitude, accessible to many amateur astronomers with telescopes and quality cameras. Composition and scientific significance. What is this third interstellar object actually made of? If we can obtain spectra of its envelope, we can compare its composition to examples from our own system. For 3I Atlas, early signs suggest ice rather than rock. As it approaches the Sun, we expect intensified heating, enabling detection of specific gases. Whatever we discover should reveal how similar this frozen body is to those born around our Sun. If Atlas proves chemically similar to local examples, it would suggest planetary building blocks, and possibly life itself, are shared across the galaxy. The importance of 3I Atlas lies in being a physical sample from another stellar system passing right through our neighborhood. Throughout human history, we've only studied samples from our own solar system. But interstellar objects like this offer chances to study chemistry and conditions around other stars without sending spacecraft. Journeys that with current technology will require tens of thousands of years. With 3 samples, we can begin estimating how common these interstellar wanderers really are. We're entering a new discovery age. The Vera C. Rubin Observatory in Chile began operations this year, and experts predict it could discover several new interstellar objects over the next decade. For 3I Atlas itself, there's no spacecraft visit plan currently. It was discovered just months before its closest approach. But lessons learned now will be invaluable for future missions. As scientists note, even our fastest rockets would take tens of thousands of years to reach the nearest stars. An object like this brings a peace to us. That's an opportunity we can't afford to waste. Final observations. Should we panic about 3I Atlas? Absolutely not. We should marvel at it. It's a reminder that space isn't a closed system. Matter, and perhaps even life seeds, can travel from star to star. Right now, astronomers worldwide are turning telescopes toward the third interstellar object, capturing images on clear nights, measuring brightness, and refining orbital calculations. Scientists know it might be decades or more before we get another opportunity like this. This visitor from another stellar system will soon be gone, but what we learn will stay with us forever, bringing us one step closer to understanding our place in a universe full of wanderers.